Good afternoon, ladies and gentlemen. As most of you know, I am Abdulahad from Molecular Biology and Genetics Department. I am here today to present solar fuels. It's a developing and promising technology, but it has some disadvantages, and I'm going to talk about two of them. Here, as you can see on outline, first one is named as inefficiency of biological method, and second one is named as lack of proper catalyst usable in solar fuels. But first of all, I'd like to begin by making clear explanation of what solar fuels are. Solar fuels, or artificial photosynthesis or artificial leaves, is a technology as defined in an article of Screen Temperature named Artificial Photosynthesis for Solar Fuels, which is based on splitting water with help of light-driving catalysts. Thus, the electricity can be generated taking water itself as a fuel directly, or carbon-based fuels like alcohols or lipids can be produced photosynthetically. Because water and light are abundant and renewable sources to supply increasing energy necessity of mankind, this technology promising being main energy source of energy production way of the future. Developers are aware of it, and let's look at this graph. Here you can see since 2000 there is a vast increase in survey of this technology. The number of research networks represent this case. Indeed, after 2007, the number of research networks rose suddenly on the United States and Europe. However, this technology faces with some issues. First, let's talk about inefficiency of biological method. A photosynthetic microorganism harvests the solar energy and gives a fuel in a high yield, and the fuel is secreted from cells. However, this method is not efficient practically. A microorganism is a living unit, and you must use energy to maintain its life. Moreover, photosynthesis is an inefficient way. As noted by Elan and GDL, only 29.2% of solar radiation polygon photosynthetic microorganism can be used to produce biological compounds. Besides, if you look at this table taken from the same article I mentioned before, taken from an article named Metabolic Engineering of Cyanobacteria for 1-butanol production from carbon dioxide, you see that the certain amount of energy, it is represented here as photon numbers, photons required. 40 kilogram glucose per meter square per year is produced with a certain energy. Same energy gives yield only 16.5 kilogram 1-butanol per meter square per year. By the way, glucose is the main energy, main food source of all livings. And this 16.5 kilogram 1-butanol energetically equals 14 kilogram gasoline. And where does that lead us? At this technological level, we should make a choice between food or fuel weighed in a third amount of food. Now we will move on to how due to lack of proper chemical catalysis. Considering statement of Alan G. Bart, is a chemistry professor from the University of Texas. Water itself does not have ability to absorb radiation within solar spectrum. Thus, photoconverters, light absorbing units, species are needed to convert light energy to chemical energy. On the other hand, as another professor from Arizona State University, Damascus noted, researchers have not discovered yet proper chemical catalysis for water splitting process or fuel production yet. Out of hydrogen gas can be produced with platinum or hydrogen enzymes or radium oxide nanoparticles. These systems have low efficiencies. As a conclusion, I can say that importance of solar energy is understood better every passing day. Solar fuel seems to be the major energy source of mankind, which we want exactly clean, easily accessible, and cheap energy. However, this technology faces with some disadvantages, problems should be overcome, and I mentioned about 2 of them. Thanks for listening. If you are interested in solar fuels, here's my reference list. If you have any question, you can ask me.